I'm a firm believer that additive manufacturing is going to play a very significant role in the future of nuclear. Being able to design, build, and certify systems in a short timelines and reduce costs is absolutely necessary to the future and health of this industry. It's very obvious to me that these techniques are going to become routine in a decade or so for production, certification, and deployment of these systems. At Oak Ridge, we've additively manufactured a whole range of materials, from ceramics, polymers, to metals at different scales. Much like many other areas where the National Laboratory plays a significant role in taking early stage applied R&D and getting it to a level of maturity and technology readiness level that can be adopted by the industry, we have the same opportunity in additive manufacturing. Our industrial partners can bring us very specific problems that we're not aware of, and we can match our technical expertise and capabilities in our facilities to answer those problems. Through these kinds of partnerships, you can make a significant and meaningful impact.
Obviously, we're working very hard to try to, I think as an administration, to try to make it very attractive to work in the United States and manufacture in the U.S. But from a Department of Energy point of view, what we're particularly focused on is what's the next wave of technologies in manufacturing that are really value added, that are unique. From a metals point of view, a number of different industries are beginning to take what we help develop to actually make components. So for example, GE and some of the aircraft engines, and SpaceX and some of its rocket components are already using 3D printing for individual parts. We think that we could actually make components for nuclear that have higher performance, and we could actually manufacture them cheaper and faster. So the question is what sort of capital, what sort of industry can stand up much larger additive manufacturing plants that they could grab onto and move the ball forward and make it part of the next wave of technologies for the U.S. economy and for the American worker.
So please join me in thanking the team in the DOE's Office of Nuclear Energy for providing that interesting peek into the future of nuclear energy. So as our next panel is coming on the stage, some of you may know that nuclear energy was first used to be converted to electricity in this laboratory about 70 years ago. And since that time, the national laboratories have played a vital role in the development of nuclear energy, and we appreciate the department's role in driving innovation in this key energy area. Now I'm pleased to introduce Ed McGinnis, Principal Deputy Assistant Secretary for the Department of Energy's Office of Nuclear Energy, to tell you more about the work of that office and to set the stage for our panel on advanced manufacturing for nuclear applications. Mr. McGinnis leads a program of research aimed at achieving the administration's goals in developing advanced reactor systems and fuel technologies, as well as enhancing the long-term viability and competitiveness of the existing U.S. reactor fleet. He has a deep knowledge and experience in nuclear energy, having served as Deputy Assistant Secretary for the International Nuclear Energy Policy and Cooperation at DOE, the Chair of the Steering Committee of the International Framework for Nuclear Energy Cooperation, Vice Chair and Principal U.S. Representative to the Generation 4 International Forum, and Senior Advisor and Special Assistant to 4 Assistant Secretaries and Deputy Administrators for Nonproliferation and National Security at DOE. Please join me in welcoming Ed.
Right behind you.
Right there he is, okay.
Thank you very much. Good afternoon. It's great to be here, and it's a real privilege to be able to speak for a couple of minutes before this really amazing panel. We've got industry leadership, CEOs. I want to congratulate Jeff, Lyash, for your new position, incredibly important position. So I just wanted to offer a little context about nuclear energy and advanced manufacturing. And I cannot but say, starting out with those two combinations, one has to recognize how absolutely fitting it is to be saying that here at Oak Ridge National Laboratory, where Oak Ridge and our other national labs literally gave birth to the nuclear industry as we know it today. It has been an incredible gift given to us, and that gift is continuing to be given 39 years, the average age of our 98 units. And it is performing, I think, even beyond most individuals' expectations. Who could have imagined that we could have a fleet continuing to provide 20% of the electricity, 60% almost of our non-carbon emitting generating sources over 30 years without any start to finish new builds. That is an incredible testament to the utilities and the leadership in our country. But that gift was born out of innovation, and at the time in the 40s and 50s, absolutely advanced manufacturing. When you think about when it all started with pile one under the squash courts in Chicago, and then at that time, Oak Ridge National Lab was leading in demonstrating the ability to what is today the ability to produce fuel, uranium fuel, enriched fuel for our fleet and the world. And then you have Idaho National Lab bringing on the experimental breeder reactor and showing you can have power right to light bulbs, and emphatically saying nuclear energy has arrived for peaceful purposes. And we have seen also, shortly after that shipping port, we see Nautilus, revolutionary applications coming from nuclear, innovation, advanced manufacturing. So we are still benefiting from an incredible contribution made by greats from a previous generation, Enrico Fermi, Rickover, and many others. And this gift today is still, after essentially 70 years, utterly unique around the world. We're all of the above, and I'm proud to say that I love wind, solar, clean coal, natural gas. But nuclear plays a vital, necessary, not sufficient, but absolutely necessary element to our nation's energy mix and to the global electricity mix. Nuclear energy, there is no other source of electricity, still based on a gift that came from us through innovators back in the 50s and 60s and 70s. There is no other generating source on the planet that can go all out, full power, for 18 to 24 months, rain, sleet, or snow, with no carbon emission, and provide that type of electricity. It is utterly unique. The density of power is utterly unique. There's over 7,700 generating plants of all shapes and sizes around the country. And if you think about the density of power, think about this: 59 of those 7,700 generating plants are nuclear. Less than 1% of generating plants in this country generates 20% of the electricity and 60% of the carbon free. That is called density of power. That is from innovation. That is from advanced manufacturing successes we've had. So it brings us to today. Many times we've seen great disruption, great innovation in our country when our back's against the wall. Our back is against the wall for nuclear right now, but not in a negative way, in a positive way. We've had this incredible gift of the fleet, and it is progressing towards retirement. We have some premature closures as well. It is this generation's moment. It's Oak Ridge National Lab, it's Idaho National Lab, it's our 17 national labs in partnership strongly with industry for us now to step up and leave our mark through advanced manufacturing, through additive manufacturing, to support the next generation of nuclear reactors. Small modular, scalable, versatile, multi-purpose, distributed in a way we've never seen before. TVA, incredible success, close to receiving an early site permit that will allow our nation's first early site permit based on a passively safe system that doesn't have a core melt scenario. It's a walk-away safe reactor. That means you should be able to, and you have an opportunity to demonstrate to boundary and not 10-mile emergency planning zone planning. So the implications are huge because of the innovations we're making. But it is time for us to step up. The labs and industry are stepping up. And I can tell you that, I think it was last time I was here, I was in a conference room, and Thomas Zachariah was briefing the labs representatives in headquarters on this idea. That is 3D printing of a reactor. And it piqued my interest, and after the meeting, I said, what's going on with that? That sounds very interesting. He said, we're working on something. And I said, let's talk more. We are now, Thomas and I and others have thrown in, Mark and others, to say this is a classic opportunity for great innovation with great impact, great disruption in our market through advanced manufacturing. In this case, multi-alloy, laser-based, fusion-based, powder bed-based, among other applications. 3D printing, additive manufacturing of components of a microreactor that could potentially be scaled up to even a larger generating asset. That's disruption. And so I remember with Senator Alexander, Thomas and I were talking about it, and we knew Senator Alexander was going to come over. And we looked at each other and we thought, okay, is this the time to go all in and say, we are going to go after the world's first 3D printed microreactor? And so we looked at each other and we saw Senator Alexander, and I told him what we were thinking about. He looked at Thomas and he said, Thomas, a 3D printed reactor? Is that possible? And Thomas said, it is audacious, Senator, but yes, I believe it's possible. We went running to the races from then. We have put $30 million down payment this year to have in 48 months the world's first 3D printed core for a microreactor with all the advanced manufacturing that goes into it. We're working with the NRC to make sure this is not just a sandbox, but a true investment that can get into the market. This transformational challenge reactor is emblematic of the ability, the opportunities. As the Secretary has said in the past, the ability and the position of our national labs to literally change the world and to have incredible innovation to drive an entirely new generation of nuclear generating technologies, advanced fuels, advanced manufacturing. And so it's an amazing time for nuclear. It's an amazing marriage of innovation, of advanced manufacturing. And most importantly, we're about supporting the success of industry. That is it. Our job, our goal, just as Connor has said so many times, our goal is to support the success of our industry. They're the greatest innovators with our labs. That marriage is strong, and we are absolutely committed to supporting our legacy, this generation. It's time for us to step up, just like in the 40s and 50s. It's our time to bring in now next generation of advanced nuclear. So thank you all very much. Oh, and I should say, I'm sorry, one of the pivotal leaders within the Department of Energy in realizing innovation, leveraging the great capability of our national labs is Dr. Mark Peters. He and I have been absolutely living and breathing, supporting the next generation of nuclear. And he has an amazing number of audacious and incredibly promising efforts on his plate, ranging from a $3 to $6 billion versatile test reactor, our nation's first since the 90s, the proving ground for small modular reactors, micro reactors, even DOD, advanced fuels, back and recycle, you name it. Let's not forget DHS, Navy, and so many others. So I want to recognize Mark and also thank him for his leadership. So thank you very much, Mark.
Appreciate it. Morning. Thanks, Ed, for your remarks and for your leadership, and appreciate it very much. How's everybody this morning? You good? It's us between lunch, guys. So you got to rock. So Ed captured really fundamentally the important points that we needed to make before we start the panel. I just want to reemphasize that advanced manufacturing defined broadly can sort of intersect the nuclear sector, the existing fleet, and also the future reactor systems in many different ways. And so we've got a great panel that will be able to touch on different aspects of that. But I would reemphasize that a lot of times it's about cost. It's about accelerating innovation and accelerating getting to deployment. And that was discussed during Mo's panel as well. It's sort of across the board, right? But particularly in the nuclear space, you really need to think about how do we accelerate to get to deployment. And advanced manufacturing is one of the really important ways that we need to think about doing that. And again, it's going to depend on the system that you're trying to manufacture. Nuclear systems are large with many moving parts, and so there's lots of different ways you could imagine, from printing an entire reactor to printing fuel to printing parts for steam generators, you name it. But I would also bring up that if we're serious about rebuilding the nuclear industry in the United States, there's also an opportunity for us to rebuild the supply and value chain in the United States around advanced manufacturing. So we're going to hear a little bit about supply value chain as we go through here, but I would say that is the grand opportunity. And if you're serious about U.S. leadership, you need to have not only us developing and designing and deploying reactors here in the U.S. and globally, but also you need to reestablish the supply and value chain for nuclear energy. And so advanced manufacturing is that opportunity. I would reemphasize what Ed also said already about partnership. The laboratories, we're here at an XLab Summit. Suffice to say, the laboratories are very, very interested, anxious, want to continue to deepen our partnerships with industry. As you heard from the Secretary this morning, that is the way that we make our research and development relevant. It has to actually ultimately get out into the market to make a difference. So we as laboratories are deeply committed to that. I'll put in a side plug again for the technology showcase. You've heard quite a bit about a couple of the labs, but it's interesting, if you look across the lab system in terms of research in the advanced manufacturing space, it's clearly Oak Ridge, it's clearly the science labs, but also the weapons labs, the NNSA labs have strong capability in that area, and also the basic science labs also have interesting capability. So I would encourage you to go out there, have a look at the showcase, and meet people. The goal the labs have here is to meet you all, talk to you about what you need, what your needs and requirements are, and walk away with follow-on discussions. To me, these are most useful if there's follow-on. Real collaborations, real discussions about how we can help industry, and that's why we're doing these summits. So with that, I'm going to introduce briefly the panelists, and then I'm going to do it a little bit different than Mo did it. I'm going to let each of them make some opening remarks, and then we'll go through questions if that's okay with you all. So I'm going to start to my immediate left. It's a pleasure to introduce Jeff Lyash. What, you said 30 days?
Yeah, today's day 30.
So day 30 of being the President and CEO of Tennessee Valley Authority, formerly Ontario Power Generation. Welcome to the United States.
Well, thanks.
And Tennessee.
I'm glad to be back.
It's good to have you.
Yeah, literally this is day 30 for me. So really pleased to be here. And I just got to say to the folks from Oak Ridge and DOE, it's been a long partnership between TVA and those two great organizations. It's accomplished so much over the decades, and my hope is that we're going to build on that. We're going to do more great things together, including this area, which is making our nuclear resource effective. So, Mark, I just a couple of comments I'd make contextually are that I believe over the next 2 or 3 decades, if we deploy technology correctly, we're going to see the amount of end-use energy we use to drive our economy and our lives actually decrease. We'll be more efficient, we'll be more effective. But even as the pie shrinks a bit because of those efforts, I believe the piece of the pie that is provided by electricity as the delivery mechanism for large amounts of affordable, small environmental footprint energy is going to grow. And that's our challenge. How do we grow that slice of pie, of the pie coming from the electricity system? And how do we do it at a cost people can afford and without greenhouse gas emissions, so that electricity can be used to decarbonize other sectors of the economy? Transportation, space heating, industrial and commercial processes. And I think nuclear power is going to have to play a key role in this. TVA, you may not realize, since 2005, has reduced its carbon emissions by 54%. It's a surprising number if you haven't heard it, and it's not something that I think other utilities can say. So how did we do it? Well, we finished Watts Bar Unit 2. We uprated the existing nuclear fleet to a higher power level. We increased the reliability and safety of that fleet and raised its capacity factor so that today, 40% of the energy we provide to the Tennessee Valley comes from our nuclear assets. For those assets to extend their lives from 20 to 40 to 60 to 80 years, which I believe the fleet in the US can do, we are going to have to deploy new technologies and new techniques to improve its safety and reliability and lower its cost. The same can be said with the next generation of nuclear plants. So among those technologies that are critical are certainly digital technologies, advanced sensors, machine learning, and AI to help us improve reliability and safety. But the topic for today, advanced manufacturing, sits there, right there in that suite of technologies. Because as we extend the lives of these existing nuclear fleets, the ability to shorten the lead time, lower the cost of components that have to be replaced in these plants, some of which are obsolete and cost tens or hundreds of thousands of dollars to try to reverse engineer and manufacture under existing processes. If we can bring advanced manufacturing to bear,